So previously in the course, we talked about prokaryotic cells, which are considered to be simple cells, even though they have a lot going on with them. Those are the bacteria cells. We talked about prokaryotic cells, and they're much smaller than what we would call a eukaryotic cell. A eukaryotic cell is a type of cell that has a nucleus and other organelles. You can see it towards the bottom. We consider fungus, animal cells, plant cells, all types of eukaryotic cells, along with this category of organisms called protists, which are single-celled organisms, things like algae, protozoans, and something you probably don't deal with too much called slime molds. So remember, the bacteria are really small, and then all those other organisms tend to be larger. Well, what is kind of hard to understand or get is that as we increase our size, we can have certain problems. So if you look at this diagram here, the left column where you've got a small cube, and it just says 1, so that's referring to the size of each side on that cube. Each side has a measurement of 1, and whether it's 1 micron or nanometer, well, it's going to be a little bit small, but you get the idea. Some sort of abstract unit. So if you do the surface area of one side on that cube, it has a surface area of 1. Now keep in mind, each side, there are 6 sides to that cube. Think of it as of dice, okay? You know, when you're rolling dice, they have 6 sides. So if you have a surface area of 1, and then you have 6 sides to that cube, you have a total surface area of 6. So as the cells get larger, i.e. going from a prokaryotic cell to a eukaryotic cell, the sides will get larger. So you look at the middle column. All right. Now in this case, each side is 5 times longer. And if you were to do the math, the surface area on one of the sides would be 25 whatever units squared, 25 square units. Remember, we have 6 sides, so the total surface area on that cube is going to be 150. So 25 times 6. Now, if you go back to that smaller cube, you can see that we have a total surface area, but then go to the volume. So the volume would be 1 times 1 times 1, because each side is 1, or for a total volume of 1. But if you go to our larger cell, our middle cell here, its volume is 5 times 5 times 5, or 125. And this ends up being a problem because each cell wants to take materials from the outside and bring them inside and then utilize them in one way, shape, or form. Likewise, it will have waste products that it will want to take from the inside and get to the outside. So in our cell in the middle that has a side of 5, that's going to be problematic because the surface area to volume ratio is too low for it to be a very efficient, versus our smaller cell, which has, if you look towards the bottom row here, that has a 6-to-1 surface area to volume ratio, versus our middle cell, which has a 1.2-to-1 surface area to volume ratio. The way in which they calculated is they took 150, which is the total surface area, and divided it by 125 to get 1.2. So it's almost a 1-to-1 ratio, not quite. And that's just too low in order for the cell to be efficient and to be able to thrive. So what's the solution? Well, not too surprisingly, if you look on the far right, if you could take the that larger middle cell and kind of almost like chop it up, make it a bunch of little cells, what that does is it increases the total surface area by quite a bit, almost like 6 times. So what we're doing is we're taking a large cell and we're compartmentalizing it. We're making a bunch of little spaces, and thus increasing the total surface area by quite a bit. But yet the volume stays the same. Okay, still 5 times 5 times 5. And then ultimately what happens is when you do the surface area to volume ratio, if you calculate that, you get a 6-to-1 ratio again. So what those little compartments end up being in the eukaryotic cell are organelles. So things like the nucleus, things like the endoplasmic reticulum, something called the Golgi apparatus, mitochondria, chloroplasts, just to name a few, which we will be talking about as we go over kind of the eukaryotic cell. So you're gonna find that inside of the eukaryotic cell there are going to be more membranes versus the prokaryotic cell that didn't have any membranous materials, or at least very little membranous materials inside. Remember, it had a nucleoid that wasn't surrounded by a membrane, versus the eukaryotic cell, which will have a nucleus, which has all the DNA material surrounded by a membrane. Ultimately, this is going to give it, is going to allow the distribution of materials inside and outside of the cell to be very efficient and allow the cell to kind of optimize its ability to function. And one analogy you could think about is, I don't know if any of you have ever lived in a studio apartment. I know I have. They're very small and they don't have very many compartments. I lived in one in like 2007, 2008 for a few months while I was kind of transitioning from one place to another. And my studio apartment had one kind of medium-sized room and a bathroom. And in that medium-sized room, I had a kitchen, I had a closet, I had a bed, and a chair, and that was it. Pretty much like a prokaryotic cell, all the functions, or most of the functions, are all in that one area. Okay. Since then, unfortunately, I've upgraded, and by quite, I'm not even sure by the square footage. But as I've moved into bigger and bigger places, you got more and more rooms. And each room, has its own function. You got the living room, you got a kitchen, dining area, bedrooms, still bathrooms, more closets. All right, and that's kind of like the organelles. Each organelle has its own function, much like each room in your home, apartment, wherever you may be living, has its own function. And that allows us kind of a division of labor. It allows us to be more organized. Allows us to keep entropy and disorganization kind of out of our lives, hopefully. Please don't look at my computer screen. Anyway, that allows the cells then to get larger and to function just as well as a smaller cell. So just to review, our eukaryotic cells, they're characterized by having a DNA in a nucleus and then membrane-bound organelles. So think about that cell on the right that has a bunch of, it's large, but it has a bunch of little cubes within it. Those are the organelles. And that's all I have to say about surface area to volume ratio, but just keep in mind, this is why the organelles came about. This is why we have them and why, and it's allowed the cells to get larger. If that didn't happen, we wouldn't have large cells. Maybe we wouldn't even have multicellular organisms. And that would be kind of a problem for us. So that's all I have to say.